Hello everyone, I am Jeevita, an assistant professor in the Department of Biomedical Engineering at SNS College of Technology. In today's lecture, we are going to see about mechanical properties of biomaterials. In previous lecture, we saw about what is biomaterials. Biomaterials is the materials used to replace, repair and support the part of human body. It is work inside the human body without causing any harm to the human body. It does interact with the human tissues, so it need to be biocompatible. In this lecture we see what is mechanical properties of biomaterials. The mechanical properties are very important to choose a right biomaterial for a right application, because it determines how the materials behave inside the body when force is applied. So the mechanical properties of biomaterials refer to how these materials respond to mechanical forces such as stress, strain or pressure. Mechanical properties are tensile, shear property and bending property and time dependent property. Now, what is tensile property? It is describe how material behave when it is pulling along its strength. It is very important to design a biomaterial implants like tendon, cardiac vessels and blood vessels. It is need to withstand the stretching. So the tensile property is very important, and there are some key concepts are there. Tensile strength is how much stress that the material can withstand before it breaks is tensile strength, and elongation means how much the material can stretching before it breaks is elongation. If a material has high elongation, it's stretching a lot. If a material has low elongation, the material does not stretch. And another is young modulus. Young modulus tells how the material is stiff or stretchy. If the material has high young modulus, the material is stiff like metals. If the material has low young modulus, it is stretchy like rubber band. You imagine you have one rope, you pulling from both in at you pulling harder and harder. At one point of time the rope going to break. That how much stress it can handle with before it breaking, it is tensile strength. To measure this, we done a tensile test. It is a sample is pulled until it breaks and the force is elongation or record. These are the formulas to test a tensile stress and tensile strain. Tensile strength denoted as sigma. It is the internal force per unit area developed when it is applied to an external force. And a tensile strain is how much the material can stretch as tensile strain. And then shear property. When one part of material slides to another part, it is called shear force. The shear property tells how the material handle this shearing force. A shear strength is a maximum sliding force the material can handle. Consider if we have a one paper and scissor. The paper has low shear strength, so it is cut easily. Some materials have high shear strength, so it resists the cutting. These are the formulas to measure the shear stress and shear strain. When we know how the material handle this shear and strain, we can avoid in some applications. So we use this formulas to identify their shear stress and shear strain. And then bending property. Bending means when the material subjected to a force, how it making a curve. This is very important to know how the material behave when we apply the force, whether they are bend or break. So the bending properties are very important to know. It is also known as flexible strength and flexion. Time dependent properties are very important to measure in biomaterials. It is describe how the biomaterial responds to a stress or strain change over the time. And Creep. Creep is a slow and gradual loss of deformation of a material when it is under the cyclic load of stress. So example is a spinal disc implant under continuous load from body weight slowly deforms. And stress relaxation. Stress relaxation is the gradual decrease in stress under a constant strain. Example, in sutures or orthodontic wires, tension reduces over time while the material stays stretched. Viscoelasticity. Viscoelasticity material exhibit both viscous and elasticity behavior. Deformation is the temporary change in shape and size of a material when we apply a force. Once the force is removed, the material returns to its original shape. The elasticity means its ability of the material to bounce back its original shape and size. When we apply the force below the elastic limit, the material can back to its original shape. It is also called a heel point. Then plastic deformation. It is the permanent change in shape or size of the material when we apply the force. When we apply the force beyond the elastic limit, the material does not back to its original shape and material undergoes the irreversible structural changes. When we choose a biomaterial, we need to consider these mechanical properties. Thank you.